Permito simplemente mencionar los integrantes de esta mesa: Mr. Hugo Gui, Mr. Rick Henniford, ingeniero Ricardo Vite Herrera, ingeniero Marco Antonio Galicia Gleason, por supuesto el ingeniero Enrique Aguilar Rodríguez, quien es el presidente nacional del Instituto Mexicano de Ingenieros Químicos, quien está también en este caso. Y les comento inicialmente, el señor Gui, que es nuestro primer orador, va a presentar al señor Henniford. El señor Hugo Gui inició su vida laboral en la Marina, llegando a ocupar el puesto de primer oficial en buques tanque. Se unió a Conoco en 1978 como superintendente de operaciones. Hugo laboró en Conoco por 30 años, donde ocupó varias posiciones gerenciales. Antes de unirse al equipo de C&J, de Simon Janssen, en 2007 como el vicepresidente de COQUIZACION retardada. Hugo fue también el director administrativo de la división de fibra de carbón de Conoco en Ámsterdam. Después de la fusión de Conoco con Philips, Hugo laboró en el grupo licenciador de COQUIZACION retardada, siendo responsable de Europa, África y el Medio Oriente. Queda en uso de la palabra Hugo Gui.
We are going to start now the technical sessions, and I'm extremely pleased to introduce to you Bechtel. And I'm also very happy that Mr. Tami, you have chosen Bechtel's license, because to me it's not because I'm coming from Bechtel, but it's from Conoco. It is the premier licensor with most experience in the world on the late cokers. You guys took the right decision. It's going to be an environmental unit, it's going to be an optimized unit. You should be very happy, and I'm proud of you guys having done that. Bechtel Hydrocarbon Technology Solutions is a wholly owned subsidiary of Bechtel. And Bechtel, everybody knows Bechtel is a big engineering company with the front-end engineering and licensing technologies in the refining and petrochemical industries. Rick Henniford is a coker technologist with Bechtel Hydrocarbon Technology Solutions in Houston. He joined Bechtel in 2011 as part of the TruePlus delayed coking technology purchased from ConocoPhillips. Rick has 32 years of experience in the petroleum and refining industry in various operations and engineering with Bechtel and also with Conoco. For the last 19 years he has been involved in delayed coking. If you're talking about a coker expert, he is one. And by the way, he's part of my code club. Rick, it's up to you. Go ahead.
Thank you, Hugo, for that very nice introduction. And thank you to Pemex for this wonderful opportunity to meet with you and talk about cokers with you this morning. It's one of my favorite topics. This morning, I would like to introduce to you the highlights of the TruePlus delayed coking technology, and I'll start with providing a very brief background for where the technology has come from. And since Pemex is very familiar with coker operations, there we go. I think I will skip over the general process description. At the end of my talk, if anyone has any questions in particular about the coker process, the general process, feel free to ask. I would certainly be happy to answer those questions. After that, I think we will go directly to discussing the more interesting challenges to operating a delayed coker cleanly, safely, and reliably. And then we will explore how the TruePlus technology addresses those issues. I will primarily focus on safety issues and reliability issues. Environmental issues will be discussed later today in a separate presentation. As Hugo mentioned, Bechtel purchased the TruePlus delayed coker technology from ConocoPhillips in 2011. Prior to that, ConocoPhillips, and before that Conoco, had a very extensive operating experience in delay cokers. Beginning in the 1950s, when Conoco built their first coker at the Ponca City refinery in Oklahoma. Over the next 30 years, they developed extensive operating experience and added cokers at added 2 cokers at the Lake Charles, Louisiana refinery, 2 cokers at the Humber, England refinery, and a coker at the Billings, Montana refinery. In the 1980s, Conoco began to license the coker technology, and the strategy for licensing their technology and their know-how was to gain experience and knowledge from outside of their own refineries to learn how to better run their own cokers, and also as a tool for, or leverage for getting into large-scale joint venture projects with other companies, such as Petronas in Malaysia, PDVSA in Venezuela. In 1994, Conoco and Bechtel first began working together on cokers and developed the Conoco-Bechtel Alliance, which was quite successful in licensing cokers all over the world. In 2005, that alliance was strengthened and it continues until the purchase of the technology by Bechtel. So in summary, the technology is based on about 60 years of operating experience, gathered in 19 wholly owned and operated cokers by ConocoPhillips, and in 45 grassroots and revamp units with other companies around the world. We have been licensing cokers for about 30 years. And we will, as I mentioned, we'll skip through these general process discussions and go directly to what are the challenges in operating a coker safely, reliably, and cleanly. First, we'll talk about safety, because that, after all, is the most important aspect to operating a coker. It's a high temperature process. The feed and some of the products are very hot, difficult to handle. We have a solid product, which is unique in the refinery, which is also exists in the coke drums at a very high temperature. Process vessels, large process vessels, so that the coke drums are opened and entered into every day routinely, which is also a unique aspect in the refinery. The process involves very intensive manual operations and procedures, which must be followed exactly and in the correct sequence, or you risk releasing hot hydrocarbon to the atmosphere with a large likelihood of having a fire. We have a limited number of process variables that we can control to operate the process. We have temperature and pressure primarily. The coking process in the coke drums must be carried out very tightly and well controlled using these minimum variables, or we can have unsafe drums, unsafe coke in the drums. All of these activities occur on an elevated structure with limited access and egress routes or ways to get off of the structure in case of an emergency. And of course, there are always the difficulties of handling shot coke, which can have blowouts or explosive releases of coke, steam, and hot water out of the top of the coke drum or out the bottom of the coke drum. The coke can be unstable in the drum and can fall and pin the drill stem, which results in extended cycle time, loss of throughput. In many ways, this process is unique in the refinery. There are many economic challenges as well. Feed properties change every day, sometimes every hour. The product specifications and the value of those products and the availability of the downstream units to process those products can change unexpectedly. The very operating conditions of the coker can cause fouling in the critical equipment, such as the fractionator, the piping around the coke drums, and of course the furnace can see high fouling rates and will require routinely being shut down or slowed down to remove this coke. There is a lot of mechanical equipment that is exposed to the weather and operating at severe conditions. It requires frequent and extensive preventive maintenance to maintain reliability. All of these issues can have a significant impact on the reliability and on-stream factor of the unit unless the design properly takes these needs into account. As I mentioned, there are environmental challenges to operating a coker as well. They're becoming ever increasingly more restrictive. We will discuss these in more detail later on this afternoon. So how does True Plus technology meet all these challenges? First, of course, we'll discuss the safety issues. The philosophy that BEHTS has, and that was derived from the Conoco operating experience, is to, whenever possible, remove the operator from the hazard. What this means is minimize the time that the operator is exposed to an open coke drum, minimize the time the operator has to spend on the structure, minimize the time that any personnel have to be on the structure. There have been several major advances in just in the past few years in this area. The unheading valves, of course, are probably the most significant development in coker safety in 40 years. As we show here, this is a Z&J bottom unheading valve. Our standard design easily facilitates installation of the unheading valves. We provide significant elevation or height from the bottom of the coke drum to the structure so that you can fit in any type of unheading valve that is desirable. In retrofits, we understand how to modify the bottom of the coke drum and eliminate the need for a transition spool or transition flanges, which have proven to be significant problems in many refineries. And we provide extensive and detailed mechanical specifications for the unheading valves to ensure that they are adequate for long-term service at the coker operating conditions. This is, we've worked exhaustively with Z&J and the other manufacturer of unheading valves and have developed a very useful and a detailed specification. Some of the other advances that have come into use in the past few years: remotely actuated valves for the major valves that are on the switch deck that are used to take the coke drums online and offline for decoking. The auto shift cutting bit, which eliminates the need for the operator to go to the top of the open coke drum, make an adjustment on the cutting bit and drop it back down. This, I believe, is the flow serve model. The rear pumping model is a much sleeker, cleaner design. And we also have the expertise and we've developed the instrumentation to allow remote coke cutting. In other words, cutting the coke, controlling the cutting system equipment from a remote location located safely on the ground. So there's no need for the operator to be near the top of the coke drum while he's cutting the drum. And at two ConocoPhillips sites, we have over 25 years experience with computer-controlled coke cutting. Another way that we remove the operator from the hazard is use of what we call the overhead bridge crane, or bridge crane. The crane has an enclosed protected cab for the operator to sit in and control the crane. And the cranes provide more coke handling capacity than the front end loaders, which means that the crane has the coke handling capacity to allow only moving coke when the coke cutting is finished. The front end loaders, because of the logistics of moving the front end loader back and forth, pick up the coke, come back and then dump it in a truck, or go to a crusher and drop it into the crusher, restricts the rate that you can move coke out from under the drum. The crane allows doing that only after the coke cutting is finished. With a front end loader, you often will be having an operator moving the front end loader under the drum that is being cut at the same time. And since blowouts can occur from the top or the bottom of the coke drum, this places that operator at risk. Our switch deck design is open and designed to provide good access and good egress or escape in case of an emergency. As you can see, this is a switch deck on a 4-drum coker. You've got a straight path from one end of the structure to the other that allows easy and fast escape off the structure in case of an emergency. And it provides a straight path that doesn't require going back and forth to dodge piping or valves in the case of smoke or a lot of steam restricting visibility. It also allows operators to stay in visual contact with each other when they're working together on the structure, which is an additional safety benefit. In some cases, we've found it necessary to add an additional egress route from the coke drum structure, particularly in 2-drum cokers that have the smaller structure, smaller platforms. We have used a remote stair tower with egress from the cutting deck and from the switch deck to a safe location away from the source of the hazard, usually a fire. Prevention and protection are both important parts of maintaining a safe coker as well. First, we want to prevent inappropriate actions by the operator. It's a common situation in the industry where operators go up to the coke drum structure in the middle of the night to drain a drum, open a drum, and they get on the wrong drum. They open a filling drum, release hot hydrocarbon out the drain. There have been cases where unheading valves have been opened on a live drum, and the result is almost always a large, significant fire. So we have simple and robust electronic interlocks on our valves to prevent any misadvertent opening to atmosphere. Our operating procedures will often call for independent verification of any valve movement before it happens by a third party, typically a board operator. And our operator training and guidelines are very specific on maintaining safe actions. We also know where to provide necessary protections for operators on the structure, such as radiant shielding at stairways and at valve stations, or where operators or maintenance people will be working. We use water deluge systems at the top head primarily to protect equipment, but also to help mitigate a release from the top head. We use water deluge curtains along the paths of egress to provide additional fire protection as operators try to escape off of the structure. We use a solid plating for the floors on the switch deck and the cutting deck to provide some additional fire protection. We also have a very good understanding of what causes blowouts. The coking process is an endothermic reaction. What that means is that we must be continually supplying heat into the process for the coking reactions to go to completion. If we don't allow these reactions to go to completion, that is the primary cause for leaving hot spots in the coke bed, which will lead to a blowout or an explosive release of coke when you cut the drum. Blowouts can occur, typically occur with shot cokers, but can also occur with sponge cokers. A common cause for having hot spots in the coke bed is by operating the coke drum at too low of a temperature. Poor distribution of the heat of the feed into the drum. If all the feed goes up one side, or if it takes a turning path up through the coke bed, we can leave hot spots, areas that get isolated that can cause blowouts. And if our quench water takes a similar path and bypasses areas of the coke bed, that can also leave a hot spot, which will lead to a blowout. We set our process conditions and our operating procedures as well. They are designed for shot coke handling to minimize the risk from shot coke. We have studied blowouts extensively in the ConocoPhillips refineries, and we have a good understanding of how to not eliminate them entirely, but to minimize the occurrence. Our sloped wall design, which is what we call the area under the coke drum, plays an important part in mitigating blowouts from the bottom of the coke drum. This provides a large area to dissipate the energy that is being released from a coke in a bottom blowout. This is a significant improvement over the small steel box chutes that other technologies use. The best protection for against a blowout from the top of the coke drum is to not have any personnel there if it should happen. If the cutting controls must be placed on the top deck of the coker, of the structure, then we will use a protective enclosure, a small room with steel walls, high impact glass windows, and a pressurized air system. I see that I'm running out of time, so these show the effect of a bottom blowout with the steel box chutes. You can see the chutes exit here. In this case, the blowout was so severe that it blew steam and coke and hot water all the way across the pad, knocked down a retaining wall, and pushed a small front-end loader back and away from off of the pad. And in one case in the U.S., the blowout was so severe that two people that were standing on the far edge of the pad away in a supposedly safe area were hit by hot water and coke, and it resulted in 2 fatalities. I will mention this only briefly. With the installation of unheading valves, we must move the feed to the drum from the bottom with a manual head to the side. And this can affect the distribution of heat and feed in the drum, and in several cases has resulted in severe safety issues. We have discovered a way to mitigate this with our dual inlet, which has come about as a result of 50 years of operating experience with a coker with dual inlets such as this, and extensive modeling, CFD modeling. And we have another presentation on these issues that will go into more detail later today. We also have, unfortunately, a lot of experience with handling tarry drums. You can see here is an unheading cart with a significant amount of tar laid across it. Here we have a large ball of tar coming, oozing out of the bottom of the coke drum. We have developed ways to identify when this situation may be present and how to best handle the situation, how to best open the coke drum safely. So as a quick summary, our primary goal in safety on cokers is to first, remove the operator from the hazard. Second, provide protection for personnel and equipment where it makes the most sense, and to understand how to prevent bad things from happening in the first place. There are also many economic challenges, as I mentioned before. One of the tools that BHTS has to offset the economic issues is the distillate recycle process. This is a patented process where we recycle one of the side draws from the fractionator back to the furnace in the coke drum. This helps to minimize the coke yield and improve the C5 plus liquid yields. It also gives us the opportunity to adjust the yields. We can adjust the distillate, we can increase or decrease the distillate, we can increase or decrease the gas oil production in whatever product makes the most profit for the refinery. It also helps to minimize the occurrence of hot spots and blowouts by providing more heat into the coke drum with higher velocities and better distribution across the whole coke drum. We also have another patented technology that we call zero natural recycle, where our design allows capturing all of the recycle and either exporting it as a product if the refinery has the downstream capacity for handling it, or it can also be used as a means to minimize the coke fines that can accumulate in the bottom of the fractionator, which can affect the run length of the fractionator. It's a very robust system. It's a proprietary design. I'll show us some details with it on the next slide. This can, if the natural recycle can be utilized as a product in a downstream unit, it can achieve the lowest coke yields in the industry. This is a simplified diagram of the bottom of our fractionator. The zero natural recycle consists of a sloped alpha tray that collects all of the liquid that is condensing out of the coke drum vapor line and is being dropped down out of the fractionator to be drawn off either as a product or as a circulating coke fines removal system. This prevents it from mixing with fresh feed. We also use an open spray chamber. We pay a lot of attention to the design of the spray headers to get the best coverage of the spray, the liquid sprays, to contact the coke drum vapors to get good coke fines removal out of the vapors. We have up-to-date, or state-of-the-art furnace design, a true double-fired furnace, which minimizes the peak fluxes in the gradient section and thus maximizes the furnace run length. We also have a modified version that we call the enhanced double-fired furnace, where it reduces the size and the footprint of the furnace, saves cost over the true double-fired, but provides most of the same benefit. Our estimates show that the enhanced double-fired furnace costs about 30% less than the terrace wall furnace used by other technology providers, and is about 10% less than a true double-fired furnace. Our coke drum design offers the best longevity in the industry, whereas other coke drum designs will last 3,000 to 5,000 cycles before having to make extensive crack repairs or even total replacement. Our coke drums will go 7,000 to 9,000 cycles. We have some coke drums operating at 10,000 cycles. We have a very robust design, pay a lot of attention to the metallurgy of the coke drum and the fabrication and stress relieving procedures. We have a very simple and robust blowdown system, and in the interest of time, I'll just say that our quench tower is very simple and robust. We have no bolted internal parts that can fall out, as is routinely seen with other designs. In the interest of time, I'll skip this. Our fine sealing basin is an exceptional design. It can provide the best, lowest level of coke fines in the circulating cutting water, which increases the lifetime and reliability of the cutting system. Most cutting system manufacturers begin to get concerned at levels of 1,000 ppm of coke fines in the water. We routinely can get down to 200 ppm, and sometimes it's seen 100 ppm coke fines in our circulating cutting water. This is a photograph showing the very simple underflow weirs and the inlet weir to our fine sealing basin. So
Rick,
yes.
Yeah.
This will be my last slide. I've run out of time. So, in summary, we have the technology to provide good coke yields. We can adjust the liquid yields to what suits the refinery best. We have designed in safety attributes based on our 60 years of experience, hands-on operating cokers, and from our 30 years of licensing cokers all around the world. And with that, I will open it up to any questions. Thank you for your time.
Good. So are there any questions from the floor?
Do you have experience in use the decanted oil from the bottom of the FCC fractionator?
Yes, we have several units in the ConocoPhillips system that use slurry, usually in small percentages, 5%, 10% of the feed, and it is most often used in our older cokers to help offset the asphaltene instability and the shock coat behavior in our older cokers. We see that it's in many of our cokers, speaking of the ConocoPhillips cokers, they are running at maximum throughput, 9-hour cycles or 10-hour cycle times. And to put slurry into those cokers would back out resid, which would reduce crude throughput. So there's an economic penalty that must be considered in using slurry. But on older cokers, without unheading valve, without the modern devices for safely handling shot coke, it makes a lot of sense.
Any other question?
If anyone has any other questions, we can discuss in the coffee break or at lunch.
Yeah, and we will see Rick further this afternoon. What I forgot to mention is that every speaker has 24 minutes, 25 minutes for his presentation. He has a big clock here in front of him. It didn't work for Rick, but okay.
Which I chose to ignore.
And then if you have any questions, we have 5 minutes for questions. If you can also write them down and email them to Rick or whatever. And the thing is, stay in contact with people like Rick, because these guys are coker gurus. They know what they're talking about. Thank you very much.
Gracias.